This is a continuation of Chapter 22, which covers conditional execution. Conditional execution is the same as looking at the if statement in R. The purpose of this particular video is to write a function that determines whether or not a particular year is a leap year. Here's a little bit of the motivation. The true length of a year is 365.2422 days. If instead of being 365.2422 days, a year was 365.25 days, then the years would stay in sync with the true length of a year if we simply had a leap year every 4 years. That is, if a year is evenly divisible by 4, then that would make it a leap year, and that would give us 25% of the years having a length of 366 days and 75% of the years having a length of 365 days. And of course, that's always taken care of by throwing in a February 29th whenever there's a leap year. But unfortunately, it's not 365.25 days, but rather it's 365.2422 days. So the astronomers had to come up with some type of system to take care of this. And what they did was they decided that if a year was divisible by 4, then it would be a leap year, unless it was also divisible by 100. If it was also divisible by 100, then it would not be a leap year. And finally, if a year was divisible by 4 and divisible by 100 and divisible by 400, then it would be a leap year. So this was their way of getting a true length of a year that's very, very close. It's not perfect, but very, very close to 365.2422 days. And so up top here, we're going to write a function, and we'll name that function is.leapyear. And is.leapyear will be a function, and it will have an argument, and the argument that goes in will be the year. So the first thing, and we're not going to do any error trapping here, we're going to assume that year will go in as an integer. We are going to say if year mod 4. Let's go back and review the modulo function. What year mod 4 does, it takes whatever input is there as year, and it divides by 4, and that modulo function will return the remainder. Well, if that remainder happens to be 0, then year is evenly divisible by 4, and that should be a leap year. Unless, of course, and we're going to put an and in here, that year happens to be also divisible by 100. In that case, if that's non-zero, then we do not have a leap year. And then we're going to put in an or condition here. And by the way, the reason that we're putting in a double ampersand and a double pipe is that is a condition which does not need to be vectorized. So in this case, we say if year modulo 400 is 0, in that case, it will be a leap year. So at this point, if that condition is true, we want to return true, and otherwise we want to return false, and that ends the function. Notice that there is only one statement, which is right here, if the condition is true, and there is only one condition if that, or one thing to return if that condition is false, so we don't need the curly braces, which we have here, because we have multiple statements. Now the last thing I'd like to do here is test is.leapyear. And I could test it with 1865. Put in 1984 after the famous book. Put in 2100. And then finally we'll put in the year 2000. And there we have some numbers to test it with. So we can kind of check here. 1865 is not divisible by 4 or evenly by 100 or evenly by 400. So we expect to get false. That should not be a leap year, and therefore February should have 28 days during that particular year. If you look at 1984, in that case, that one is divisible by 4. So in that case, we expect a true to come back. Now for 2100, now what we have is we have a year which is evenly divisible by 100 in addition to being evenly divisible by 4. So that one should not be a leap year. And then finally 2000 will satisfy all of the conditions. The modulo operators will all return a 0 in this case. So that one should be a leap year, so that should return a true. So highlighting all of this and hitting run, see what we get. First of all, you'll notice here that the function went through fine. There were no complaints. I didn't make any typing errors going in. And 1865 is not a leap year, so that is false. 1984 is a leap year, so that'll be a true. February will get 29 days, which means the year will be 366 days. In this case, 2100 is not a leap year, so even though it's divisible by 4, it is also divisible by 100, but not divisible by 400, so that is not a leap year. And finally, 2000 is a leap year because all of the modulos up here will return a 0, and this last one after the OR condition here will return a true. So that's the last example we have here of using conditional execution.